This is a lesson on logistic growth. For students who missed class today, May 5th, 2010, the homework tonight is assignment number 2. These two equations here are models for logistic growth. It's just like exponential growth. However, there's a maximum capacity. There's a maximum amount that the population hits. That's this number C. It's a very important concept. This is called the limit of growth, the carrying capacity, or the maximum capacity. Here's example number 1. This is the population of Dallas, Texas, T years after 1900. It follows a logistic model. We want to answer these 4 questions. What is the initial population in 1900? That's when T equals 0. What's the limit of growth? And find the end behavior. To answer the first question, what's the initial population in 1900? Think about what our T value would be. Well, since T is T years after 1900, for A, T would equal 0. So think about what would happen if we plugged in 0 for our T. So if we plug in 0 for the exponent, we get this number times 0, which is 0. And we get e to the 0. Now anything to the 0 power we know is 1. So 21.602 times 1 is 21.602. Add 1, we get 22.602. So when I plug this into my calculator, I have my final answer. The initial population in 0 years after 1900, or in the year 1900, is 57,589.68. The next concept, the next question is, what is the limit of growth? This is a very important concept. Remember, in the equation we had the numerator is C. C is the limit of growth, the maximum capacity, or the carrying capacity. Those are all synonymous. So our answer to B is 1,301,642. To answer the next questions about end behavior, we need to know what the logistic function looks like. So I'm going to show you what the logistic function looks like. We're going to graph it. So the logistic function is very similar to the exponential function in that it increases at an exponential rate. However, we have the carrying capacity. That means there is a maximum amount that this logistic function gets very close to. So here, this horizontal asymptote is our carrying capacity. The graph increases and it gets very close, but will never touch the carrying capacity. It will just approach it. So if we look for our limits, the limit as x approaches negative infinity, what y values are we getting closer to? So we're looking at the graph as x approaches negative infinity. This green line gets closer and closer to 0. So this first limit is equal to 0. In fact, for all logistic functions, it will always approach 0. Now as I approach positive infinity, I follow the graph to positive infinity. As the graph gets closer and closer to infinity, we get closer and closer to the horizontal asymptote, or our carrying capacity. So the limit as x approaches infinity is equal to the carrying capacity. Now, in this particular question, the carrying capacity happens to be equal to 1,301,642. So that would be the limit for this particular case. Let's look at another example. So here's the next example. Blake has 1,200 students. That would be our maximum capacity in this equation. Mrs. Brown starts a rumor modeled by this logistic function. There are only so many students in Blake High School that will hear the rumor. So the first question is, how many people have heard the rumor at the end of day 1, day 0? It sounds like day 1, but it's the initial day. So technically, we mathematically use day 0. when we plug into the equation. So go ahead, hit pause, plug in 0 into the logistic function, and see what you get. How many people heard the rumor on the initial day? So you should have gotten 30. When I plug in 0, I get negative 0.9 times 0, which is 0, e to the 0, which is 1. So this term right here becomes 1. 1 times 39 is 39. 39 plus 1 is 40. 1200 divided by 40 gives us 30. So there are 30 people that have heard the rumor at the end of day 0. In reality, we would call that day 1. Mathematically, since it's the initial day, we call that day 0. Next question is, how long does it take for 1,000 students to hear the rumor? So the way we're going to solve this first is we're going to plug this into our calculator. Put your equation into y1, put 1,000 into y2. Graph the function. Graph it so you can see the intersection. Then calculate the intersection and find out how many people have heard it, or how long does it take for 1,000 students to hear the rumor. After plugging in to y1 and y2 and doing second calc, intersection, enter 3 times, the calculator told me it took about 5.86 days. Well, if you think about this, this is 5 whole days plus 0.86 of the next day. So technically my answer is it took 6 days. For the next example, we need to be able to write a logistic function given the following information. Initial value is 5. That means when x equals 0, f of x equals 5. The carrying capacity is 20, and we need the point 1, 10. So first, let's put the carrying capacity. That's the easiest number to put into the equation. So put 20 in for C. The next is the initial value. So I'm going to plug in 5 for my f of x. And this is my initial value. That means x equals 0. So let's plug these numbers in and see what we can do. Plugging these numbers in, looks like the only things I have left to find are the a and the b. Well, when I plug in my initial value, b to the 0 becomes 1. Anything to the 0 power becomes 1. So this term goes away. So we're left with 5 equals 20 over 1 plus a. That gives us a chance to solve for a. Go ahead and do that. Alright, so when I solved, I found a equals 3. So there's another number I can plug into my equation. So now I know the c and I know the a. The only thing left to find is the b. I'm going to use the next point that they gave us, plug the 1 in for x, and plug in the 10 for f of x. Solve to find the a. So let's do that. So now what I did was I plugged in 10 for my f of x. I'm using the point that they gave us. I still have 20 for my c. 1 plus, we solved for a and we found a equals 3, times b, and I plugged in 1 for x from the point that they gave us. Well, now I have 3b. b to the first power is just b. So really, I don't need to write the exponent 1. So I have 10 equals 20 over 1 plus 3b. So let's go ahead and solve for b. I multiplied both sides by 1 plus 3b. That way I don't have a denominator anymore. Distribute the 10, and then go ahead and solve for b. Hopefully you got b equals 1/3. So now that we know our a and our b, let's go ahead and put all this information back together to find the logistic function. So here's our final answer. I plugged in 3 for a, and I plugged in 1/3 for my b. I plugged in 20 for my carrying capacity, and here's my final answer. This is the equation of the logistic function given these 3 pieces of information. In the homework, you will also have to be able to do the same concept given a graph. However, you follow the same steps. Here the carrying capacity is 30. Our initial value is 6, so I plug in 0, 6 first, solve for a and b. Then I would plug in 3, 12 to solve for b, and then I would put all the information back together again to find the equation. So homework tonight is assignment number 2. There's also a YouTube about exponential modeling.